Good morning. So we are in section 4.4. We were learning last 3 rules of logarithms. In total we have 7, and last 2 sessions we solved a lot of questions and applied those rules. We will continue solving a couple more questions and go to the equation solving problems. Next section 4.5 we will solve equations involving exponential functions and logarithmic functions. Okay, so this is the last thing we did yesterday. Basically what we are doing is you have a big chunk, one fat logarithm, a lot of stuff inside. We are breaking it into more pieces by the rules of multiplication, division, and power rule. Last 3 rules from the list. Where is that list? It looks like I didn't copy it here. Let's copy that. Here is the list I'm talking about. So in this question as well, you're going to employ the last 3, and sometimes you may need the first 4 as well, and break this apart. Alright, here is the lesson we got from yesterday as well when you were working on this question. What was the trick, initial trick we did in number 5? And how is it related to our current question number 8? Right, square root, or not just square roots, we call them in general radical. When you see radicals, you convert them into power. And that rule was if you have x raised to the a outside b, how do you change this into power? 1 over b, a over b. Yeah, if this is 1, if there is no power, it's 1 as default, but if there is a visible power, it's a over b. So that's what we are gonna do in the first phase. We will simply rewrite this logarithm with, instead of the 7th root, we change it into some power, and you tell me what it is. What is the new power? Aha, you're hesitating. It's 4 over 7, am I right? Am I right? What's that, Matt? Yeah, we cannot use this 4 because it's only covering the base e. If it was 4 power like that, yes, this was right. However, this 4 only belongs to e. We can't treat it as a power of the entire inside. So what shall we do then? What is the power of this entire inside then? It's just first power. Okay? Unless you can factor a power from these, default power of anything is just 1. So it's 1 over 7, the new power. Okay? Next. What shall we do next? You need to rinse and repeat. Use one of these rules at each time and break this apart. I want to see e, x squared all separated with their own logarithms. You don't have to provide the right answer, just what's your guts telling you? What would you feeling about this question? What would you do next? You would use property 6, which is division. You see a fraction here and we try to separate it. However, there is a problem. It works if you see only a fraction here with top and bottom here. To be able to separate this top and bottom in their own ways, they should not be captured under a radical or power like this. They are not free to separate. They're kinda imprisoned by this guard. It's waiting for them. They won't let top and bottom separate. So we need to first handle it's acting up somehow. Handle this guard first. So before number 6, we need to do number 7. Okay? So number 7 says if you have a power, you can pull it all the way in front. So it's 1/7 ln e to the 4th x squared plus 2. Okay? Now we can do Matty's idea and separate this division into top and bottom with 1/7 in front. It's ln of the top minus ln of the bottom. That's what the rule says, right? Top goes first, bottom goes second. I have a slight mistake somewhere. Let's see who is gonna spot it. You need to pass this 1/7. This was a coefficient of this ln. If ln splits 2 ways, this 1/7 should go with the second part as well. Or keep a parenthesis. This separated into 2 spots. So keep a parenthesis, then distribute 1/7 and get the same result. Alright, one little flaw. I won't call it a mistake. There is a flaw in my writing. What can be more proper here? If you have more than one item inside a logarithm, added or subtracted, you better keep them in parentheses like this. Otherwise, 2 looks like separated from ln. This looks like outside the ln. This is much better now. Both together I know now is under ln. Okay? Are we done? I feel like we're done.
Can you do something with the 4?
Yes, we must do something with this 4. Because it's a power. Just like this. You have a power around a base. So I can take that power out. There are 2 options you can do. You take this power out here, call it 1/7 ln e. I'm sorry, not 1/7, 4/7, because 4 goes in front and multiplies 1. And then, don't we know what ln e is? How can we know it? Because ln means logarithm with base what? E. So this is logarithm base e o e. So there is a match here. Once the base and this number match, what happens to this logarithm? This becomes, what happens? E 1. 4/7 happens. Or you could have done this another way. You don't need this. Why don't you do, what rule can you do directly here in this list? Number 3, look, it says if these 2 match and there is a power around the number, look, isn't this logarithm, ln is logarithm base e, logarithm base e4, bbp, e4, p is 4. BE is B, BBP, right? EEP. So we can just take this we can just cancel this actually. We can cancel logarithm ln e or log base e with e. and make this just 4. 1 over 7 times 4 only, this thing. Rule 3 says that. Okay? And this makes 4 over 7. Fine. We handled the first case. What is the second one? Can we do anything about this? I have a feeling we can also factor this out, or yeah, we can cancel this out and move it here. 2 in front, 2 over 7 ln x plus 2. Is my feeling right? Right. I wish the 2 was here, the square was here. You could move it, but not like this. This 2 is messing up. The 2 afterwards here, messing this up. Without this, yes, you could move this. But this 2 and x squared is a combination. It's a block. And this block must have its own power to call it out, or it won't move. There is not this square won't leave the logarithm. So there is absolutely nothing we can do in the second half. We just leave it like that, and this is our final answer. Oh, can I separate this addition here and call it as ln x squared and ln 2? Can I separate it? Is there an addition law like that? No, there is no addition law. There is nothing that can be done about addition. Okay, I have much better ideas. I don't have a square here, but I have a feeling I can do this. X squared plus 2, I can call this 2 out like this. It becomes x and root 2. Because when I pass this back in, it becomes x squared, and root 2 times root 2 is 2. Can I do that? And then I can factor this 2 from the ln. Make sense? Makes sense, right? But it's incorrect. Because when you FOIL x plus root 2, x plus root 2, it's not just the square of the first and second to make this. It's first, outside, inside, and last. It's FOIL, and it won't make this thing. So this is a misconception. You cannot factor this 2 out unless you have 3 terms. Trinomial, then you make complete into square. Alright, this is it. This is the final answer for number 8. Is it back on? That was 4 over 7 minus 1 over 7 ln. I wonder if it's gonna like this one without the parentheses and say it's incorrect or not. I didn't use a parentheses. I believe it's gonna say incorrect. Yeah, I need to use a parentheses and capture both x squared and L2 under the ln. Now it sounds correct. Okay, if you don't use a parentheses in Connect Math says, oh, why did you put that 2 outside? It should be in ln. So you must use parentheses. Alright, we are doing what we did backwards right now. Again, what did we do in number 8? You had a big fat logarithm. We chop it off into 2 pieces, 1 and 2. 2 pieces. Now, what we have here is 1, 2, 3 pieces. You're gonna do it backwards. You're gonna create one big logarithm of stuff, a lot of stuff. Okay? How do we do this? You will take back your operations. You were using addition and multiplication, turning multiplication into addition, division into subtraction. We will do it backwards now. Where do we start? Oh, let's start with copying this toolbox course, you will refer to this unless you memorize all tools. Okay? Alright, much better. Alright, tell me your ideas. Oh, I mean, there are 3 pieces. Some people just combine all at once, but I'll do 2 by 2. Choose 2 pieces and combine with one of these rules. Look, this one kinda combines a subtraction into division. This one combines an addition into multiplication. This one turns a number in front back to the power. Which one? 5, 6, 7. Which one would you apply? And which pair? First, second, third one. 1 and 2, 2 and 3, 1 and 3. You choose.
Number 6 and 1 and 2.
Do number 6 in 1 and 2. Maddie says there is a subtraction between these two. Why don't we combine them? Good idea, I like it. How about these two? Can you combine these two? 2 and 3. It has a subtraction as well. Can we do this one? No, because this guy has a negative. Look, to be able to combine these two, first one should be positive, second one negative. This one is negative, negative, won't work. Unless you do this, you can call these minuses out and make this plus, both plus, look, both plus now. And you do rule, which one is now? If it's plus, both plus. Rule, you can do rule 5, but that's just too confusing. Just take the easy ones out. Do number 1 and 2 and rule number 6. Again, doing these 2 and I'm doing rule 6. Okay? Rule 6 says, now help me. What new logarithm do you get here? Log 6 of what? 5 over 660. I put 5, 660. What's wrong? Says division. I did it. Yeah, the negative one should be in the denominator. 5 has negative, so it should be in the denominator. Alright, you still have this negative sign following that. Alright, you can divide these two if you can. Can you divide it? Or leave it to the end. Don't rush. You don't have to divide. Now combine this back to this group. How? I don't want to divide yet. You can divide, that's fine. How can you combine? If you don't know how to divide 660 and 5, if you leave it like this, how do you combine 22 with it? Any ideas? It's again rule 6. Because it's a minus. It's a plus and minus. Plus and minus. What's the answer? What's the next step? What am I gonna put here? 660 and then complete it. Come on. Five. Where do I put 22? Yeah, you have two options. You either put it right next to 5. Already you have a denominator. Put it there. Or, no, this is the first guy. This is the second guy. So these should divide. F should be divided by S. You make a bigger division and divide. But if you combine this complex fraction by flip and multiply by top, flip and multiply, you will get this 22 over 1 as 1 over 22 here, and it will combine with 5 anyways. So I will just take a shortcut, and quickly, if you see a minus, and if you already built the denominator in the first one, put that 22 right in that denominator. You don't need to create an extra division. But it's correct if you do that as well. Okay, now let's simplify. 5 and 660 simplifies to 112. Am I right? Correct? 5 goes to 660. No, it doesn't, of course. 120. 132, I believe. 132. 5 times 100 is 500. 5 times 30 is 150. 5 times 2 is 160. 660. And can we simplify 132 and 22? I believe it goes how many times into 6? I think it's 6. 6 times 2 is 12, 120. 2 times 6 is 12, 132. Perfect. Oh my god, something great is happening here. What is log base 606? It's 1. Matching pairs always make 1. This mess turns into 1. Doesn't even turns into 1 log with fat things inside, because everything is number, it's computable, so you can simplify this. Alright, do you see the power of algebra? Maybe you don't. Let me show you the power of algebra. Why are we teaching you these crazy things? You have calculators, right? Why don't we do, oh, I'm not sure I can do logarithms with Google. I will do my best. Alright, you help me. Some people say we don't need this algebra to compute this. I can hand calculate all these logarithms. We have calculators, great calculators. Why don't we use it? Okay, I need somebody to compute logarithm base 6 of 660. What would you get?
How do you do the different base?
I don't know either. I'm not a calculator guy. Yeah, even if you have a basic calculator, it won't. I think TI-84 will do it. Let me see if I can do here. Logarithm base 60. No. If it's like it or not. It wouldn't understand this. Scientific calculator. It doesn't have other logarithms. It just have log base 10. So you see, you can't even do. But what I'm trying to show here is the numbers you will get here will be approximate. Like you will get here probably, let's say I'm just throwing numbers in. 9.8. This is gonna, let's say 2.8. This is gonna be, for example, 1.7, and this is going to be 0.1, 0.19. In the end, you are gonna get a value like 0.998. Always your answers will have some error because you're rounding. Your calculator will give you an endless number. You will cut it off. You will cut this off, and you will cut that off. So in the end, when errors combine, they will make a bigger error. But if you do the algebra, there is no rounding off, there is no estimation. And in history, because of this rounding mistakes, there are catastrophic results, like a missile hit a civilian land or occupation and killed people because they rounded off the degree of the target. Okay, wrong. So that's why we always need to learn how to try to get the answer in exact answer, not round off. Yeah, if you're stuck, if the number is you're not getting it in the very end, you can make one rounding. So this is going to be a very small error comparing to there are 3 rounding here, 3 errors combining to mess that. Okay, so that's what I'm. So at home, if you have a scientific calculator that can take logarithm with base 6, try this. You will not get one if you compute one by one. All right. So we have answered this one. We're going to the next one. All right, 3 different logarithms, combine them. It is your toolbox. Maybe not. There is something tricky here. Alright, let's do this together. So, as usual, we will start the first 2. There is a subtraction. How do you combine these 2? So it's log u over v, u on the top, v on the bottom, right? It's a subtraction, rule number 6. And what do I do with 2 and 1 over 5? Yeah. We cannot combine this because they don't have the same coefficients. What shall we do with 2 and 1 over 5? Are we going to subtract them here? No, this is nonsense. So before you combine subtractions and additions, make sure they do not have any numbers in front. If they do like this, put them back inside, and this one too, and make all those coefficients numbers in front gone. This is u squared. This is log v to the 1/5, and this is log w to the 4/5. Then we can combine these two as log u squared divide v to the 1/5, and I take this guy in here because it's another rule number 6, and make my final answer as this. Okay, happy? There is one more move you can do. Remember, what did I tell you about rational powers? If you have 7 u to the 2, it's u to the 2 over 7. Same way, you can turn this u to the 2 over 7 back into rational radicals. This rational power can turn into radical. I'm not sure we are supposed to do this. Is it optional or is it required? Let's read the statement. Does it say anywhere you need to change them back? It doesn't. So I will first test this answer, right? If they don't like it, I will change the radical back to, change those powers back to radical. So we have a fraction coming in, u squared over v to the power v to the power 1/5. Was that 1/5? And go down here, w to the 4/5, right? Right? Yeah. Since there is no addition or subtractions, you don't need a parentheses. It like that. You don't have to change the radical. But in case you are wondering, you can turn this, the bottom one, into radical of v to the first power. You don't have to show first power, but with radical index 5. The second one is w fourth power with radical index 5. Since these two radicals match the same index, you can cover them with the single radical root 5, fifth root, and combine v and w under it. So these two can be combined as this, under the same roof. Okay? You can test if this is lagged in here or not. Yeah, you can make any kind of radicals. Yeah, I don't want to mess up right now, but you try it, okay? Alright, one more question. We first move the numbers in front right here. There is only one thing you need to do. So can I just do it right here, 1/3? And I will combine these two next. Log 2q to the 1/3 over q squared minus 64. Am I doing everything right? Right? And then we put this back right here. The first one is wrong. This is not division, guys. This is multiplication. Why? Because it's addition here. So it's q to the 1/3 and q squared minus 64. And this guy is gonna turn division. So it's logarithm base 2 q raised to the 1/3 q squared minus 64 over q minus 8. Alright, are we done? I think we're done. Or can you do more? We need to go for simplifying as much as possible. Do you see any simplification here? Do you guys remember square difference? If you have a difference of squares, you can write it as a plus b, a minus b. Like q squared and 8 squared is, this is q. It looks like 9, but it's my q, okay? So that's q minus 8 and cube or cube. It doesn't matter which one is minus though, but I want to fit to the formula bar. And this is q minus 8. So this top is actually q plus 8 and q minus 8. And you cancel these, you turn it into better form. This is the final answer. Okay? If you wish, you can turn this into cube root. That's cube root, right? Agree? Any questions? Are we good? Kylie, you have a question? No? Everything clear? Because it shouldn't be clear, okay? I mean, or it's okay if you're not getting some parts, so let me know. Give me feedback. Okay, then. The last question. The last question is kind of irrelevant to what we've done so far because it's completely using a new tool. It's called change of base formula. Because sometimes we have actually experienced that here. We tried to evaluate logarithm base 6 right here. I couldn't find how to make base 6. So those different bases are inconvenient for us because we don't have next to us a very highly sophisticated calculator to compute logarithm base 6. So you may want to change that. Yeah, why don't we use this? This is actually a great application. We had logarithm base 6 of 660 and I had no clue how to evaluate this in a calculator. This formula says, oh, you don't like this base? You can change it. How? This logarithm base 6 of 660 can be changed into a logarithm of, but there is a fee, it's not free, any other logarithm of any base you wish. So you choose the new base here in both spots, but there is a fee. You need to compute the number inside right here and the base right there. You need to put that base here and compute these logarithms and get to the result. Look, what base you want to choose now? New base should be something you can use your own calculator. You can do ln, you can do logarithm base 10. So I want to do logarithm base 10 and compute it. What is logarithm base 10? 660. Logarithm base 660 is 2819543. Okay, divide. What is logarithm base 10? 6. Just take logarithm base 10 6 right now. Copy this out. Didn't do a good job. Why would you copy everything? I don't know. And now we need to divide one into another. And I don't know how to copy all that. What is this one? Okay, but I need that in the denominator. Oh, how about inverse? No, that's inverse. Or I'm not good with calculators, but you need to divide these two numbers. Somebody help me. 281 over 0.77 is about 4-ish, I think. 3 point something. Just divide the first 3.6. Yeah, there you go. You computed this logarithm base 660. You couldn't do it earlier. Now I can do it. How did I do it again? Let me back up and explain again. If you have a number to compute, but the base no good for your calculator, then you can change it to any base 5 if you wish. Now let's go with base 5, but why would you change it to 5? Your computer still can't do it, but I like it. I want to change it to 5. I put 5 and 5 in both places. Take the top one here, take the bottom one here, and compute these two numbers. Compute, and divide. And you will get it here. That's it. That's what the formula says here again. This is new. I'm changing into a new base. But I take the old x here, old base here, and use them there. Okay? Make sense? Now you can compute with that simple calculator, you can compute any logarithm. Any. Because you know the formula now. Alright, this activity, this exercise is gonna make use of that rule, not in the first part though, not in part 1. We're gonna use that in part B. Okay? So part 1 is something else. We are going to part 1, before doing part 1 here, please read the entire question because it's kind of lengthy. Just read A and part 1. That's what we need to do right now. They are teaching you a method here in part A. A is an example they have given. They say you're in a deserted island. You don't have any calculators. How would you estimate logarithm base 2 of 7? You don't have a calculator. You can't use change of base method. You cannot use this because this still computes these by calculator. How would you estimate? It says this is a code you find in the island, and it says if you find roughly what this number is, you're gonna be saved from this deserted island and your life depends on it. How would you estimate it? This is what they do. You first estimate 7, this number, and try to find out 2 powers of 2. That is one of them is bigger than 7, the other one is less than 7. And we know that 2 squared is 4, 2 cubed is 8, 7 is between 2 squared and 2 cubed. But I wonder why they went with powers of 2, not powers of 3 or powers of 10. Why do you think they chose powers of 2? Why? Again, they said they used here 7 is between 2 cubed, but I could have said this. 7 is between 3 squared and 3 to the first. 3 to the first is 3. 3 squared is 9. 7 is between 3 and 9. Why did they go with 2 squared and 2 cubed, but not 3 to the 1 and 3 to the 2? Yes, because the logarithm we're supposed to compute to get out of this island has base 2. When you choose powers of 2 here rather than 3, look what's happening. Watch. 2 squared and 2 cubed here, right? when I take logarithm of all three sides with base 2, log base 2, log base 2, and log base 2, these two cancel and this guy comes here. These two cancels and this guy comes here. Look what you just did. Logarithm base 2 7 is about 2, a little more than 2 but less than 3. So you roughly know how much this value is. Between 2 a.m. and 3 a.m. there's a ship coming. Just wait us on the shore. That's what the code is. Alright, so this is giving you a roughly method to estimate value of logarithm 27. In our question, however, you have logarithm of 4 of 5. So first, ignore log 4, find two values, 5 is in between, then we use logarithm. So take some space, use some powers to put 5 between those two. What two powers 5 is between? Oh, it's the same. I can cheat here. It's between 2 square and 2 cube. Is this gonna work? Yeah, it's 8 and 4. What is wrong with that? 5 is between 8 and 4. Right? Yes, we cannot use base 2 here because logarithm is base 4. So you need to raise these numbers into powers of 4. So I'm going to go with 4 to the something, 4 to the something here. What are those? Is it square and cube? 4 square is 16. Nope, 5 is too little. So we go with 1 and 2, of course. Now introduce logarithm base 4 to both sides. Not both sides, all three sides. And they cancel. 1 is left. Right? This is on nothing left. These cancel. 2 is left. Logarithm base 4 of 5 is between 1 and 2. Make sense? Alright. What does this say? Approximate the logarithm to 4 decimals by using this. You have now a basic calculator, but that calculator cannot do logarithm base 4. Right? The calculators you have can't do base 4, but they still insist me to compute this up to 4 decimal places. So what am I gonna do? Use change of base formula, because by changing the base I can use my calculators. Just set up a fraction. What base you guys wanna use? Tell me the new base of your choice. 10, but we already used 10 twice. Why don't we go with another logarithm? Your calculators have a button for it. Natural log. Go with log base e, or ln we call it. Go with ln. What do I put next to ln? This goes to the top. This goes to the bottom. ln5 and then ln4. Look how easy this is. Compute ln5. Where is ln? Here. ln5. 160943. Just get up to 5 or 6 decimal places to be safe. Go up to 6. I go to 6. And now I'm gonna do ln4. ln4, right? Yes. 1386294. And divide one into another. I need your help. I can't do it. Again, I will use this symbol here because this is not an exact equal. I cut it off, so this is approximation. Tell me the result up to 5 digits.
1.16096.
And they want 4 decimal places, so you need to round this up. Okay, 96 becomes 6 becomes this becomes 0 and this becomes 1, right? 96 becomes 100 when you round it up. So it's 1016. Let me clearly write this. 1610. 9 turns into 10. So 10. I hope it's right. Good. Alright. They want us to make sure you got an estimate. Yeah, computer says I'm right. But if you don't have a computer to make a green check mark, how would you test this answer is right or wrong? You're saying that logarithm base 4/5 is 1.1610. How do you know? How to make sure? They say you can make sure by converting this into exponential. Do you remember the first week we dealt with exponentials and logarithms? It was box, triangle, circle method. This is triangle, this is circle, this is box. I don't know which one I called box, but you replace these, switch them around, and this turns into an exponential. Who wants to change this into exponential? Come on, you can do it. Base goes to the base. There is a power and a number. You need to figure that out. Base is base. What is the power of the base? And what is the other side? 5, and this number should go where?
Should be 4 to the power 1.160.
Perfect. We just need to test this. Take a calculator and see if 4 raised to this power is 5, almost 5 or not. It's not going to be exact 5, you need to be almost. So I will take a calculator, and I think Google can do it here. 4 raise it to the power of 1.1, what was it? 1610. Let's see if we are getting a value around 5. Oh my god, it's almost 5. We are very close, up to 3 digits. Fourth one, start deviating because it's an approximation. Again, this is not exact, it's an approximation. So we roughly want to hit 5. Have we hit roughly 5? Yes. So our answer is correct. I wonder how we check this. Oh, you just turn this into exponential. 4 raised to the power. Yes, we really check 1610 and it made almost 5. Okay. Alright, this section is over, but that doesn't mean you won't see logarithms. You will see them in equations coming up next. Any questions? You now know every trick about logarithms. We will just apply them into equations and then word problems afterwards. Here we go. Exponential and logarithmic equations and applications. It's our topic now. We will first solve equations involving exponentials. Look, the first two problems, look at them. Do you see any logarithms? No. Everything is in exponents, exponential. So we will first deal with them. How? Something we have already built before, nothing new. What is this? It says if you have on the left side of an equation something with a power and on the right side you have same base but a different power, you can we can wipe off the b's, same bases, and set x and y equal each other. Okay? So that's the trick we're gonna do. So for this, I need to prep the equation given in such a way that there will be only a base and an exponent showing up. Is this a base and an exponent format? Base and exponent. Base, exponent. So the left side is fine. It's already been raised to a power. But the right side, do you see a base and an exponent on the top? No. You need to prep the right side and make a base and exponent. When you are doing that, make sure same bases show up. So this is a pretty easy question. How would you change? We need to change 27 into base. The left side, no change required. It's the same. It's already base and exponent combination. 27 must be a power. What power? What? Cubed. 3 cubed, right? It's so easy. Now, what does this property say? If you see matching bases on either side, as I do, you can cross them out and set the leftover items equal each other, which are, in other words, exponents set into each other, and we get y equals positive 2. Subtract 7. You get minus 4. Divide both sides by negative 2. You get y equals 2. Okay? Alright. This one was easy. I took care of it quickly, but what do you think on this side? Give it a thought for a minute while I'm opening, closing unnecessary files, opening new homework. This either. No. Yes, this is your problem. Copy it down and tell me what you think. Alright, this is easy as well. I see 3's on both sides. I will just cancel them, cross them out, and set those exponents equal each other, right? That's easy. Am I right? No, it's not gonna work that way because these are not just 3's. This is 3. However, this is 1 over 3 raised into power. They are two different numbers. You need to match them. You need to play with these. Either make this 3 into 1 over 3 and cross out, or you make 1 over 3 at just 3 and cross out. Is there a way to do either case? Can you flip 3 into 1 over 3, or can you flip 1 over 3 into 3? How? How to change this into this? There is a catch. Right. 1 over 3 is 3 to the negative 1. Or 3 is 1 over 3 to the negative 1. That's 3. Okay? But this makes more sense. I want to change. We don't like fractions. Change this into power. So the left side still nothing required. On the right side, I will make this parentheses 3 to the negative 1. Now can we cross this out? Can we? Not yet. Do one more step. What is that? I see double powers. 2 powers here. Negative 1. And then it's raised into another power of w minus 2. How do you combine these two? What operation do you make? Multiplication. That's right. We multiply negative 1 and w minus 2. And negative 1 times w is negative w and minus 2. Next, I cross these out, right? And I get 3w minus 6 minus w minus 2. Any comments? Right, here is my mistake. When I multiply negative 1, you need to multiply both numbers. It's like a parentheses. Negative 1 times the parentheses w minus 2. This needs to be flipped. Needs to be positive. Next, I move this left, this right by flipping their signs. So I get 4w equals 8. W is 2. Oh, same answer. Looks like 2 is the answer all the time. This homework is easy. Any questions? Look, 2 works all the time. Incorrect. Yeah, it's not 2. Alright, next question. Ready for the next one? Well, it's the same deal. I will try to use this fact again. Just make left side into power. Oh my god, it's already a power. How great is that? And make the right side into power, guys. Make 97 into power of 2. What power of 2 is 97? And we can all go home. Fifth power, 6th, 7th, 8th. None of the whole powers of 2 is 97. Look, I can try 2 to the 5th, that's 32. Oh, we are short. Just increase one more, that's 64. Increase one more, and we pass the target. So I know there is a power between 6 and 7. I can't put my finger on it. It's 6 point something. I don't know. So our method, this method was nice, beautiful. We loved it. Unfortunately, it has very limited applications. If your numbers are nice enough, such as this was nice, 27, 1 over 3 was nice, you were lucky, you used this simple fact and got the result. But not all these numbers will be nice, such as this one. So we need to get help from logarithms. How logarithms are going to help us take care of exponential functions. You will see in these steps. Okay, we will do it in these steps. First, apply the recipe. Isolate the exponential expression on one side of the equation. So you need to know what I mean by exponential expression. What part of this equation is exponential? This part. We need to isolate this. Isolate means on that side, left side, there should not be anything around 2 to the r. Like if you have a number in front, added another number afterwards, you need to take care of them. Do you see anything around 2 to the r? Do you? No, it's already been isolated for us. Isolated already. So step 1 is done. How about this one? No. Exponential expression is here. Do you see only this thing on this side? Has it been isolated yet? No. We need to take care of this one. Move it by some trick. We will see. But right now step 1 is void. It's not necessary. Second, take a logarithm of the same base on both sides of equation. What base do you see on this exponential expression? What is the base? 2. So you will take logarithm of both sides with that same base 2. And 2 to the r is still on the left. Make sense? I'm wondering why they are taking base 2 but not base 5. Why? Why don't we take base 5? But not base 8, but not why base 2? Why do you think they are taking base 2? Right. So we can have a match between these bases and cancel by rule number, what rule is it? Number 3? Rule number 3 in our toolbox says if you have BBX, these two matching, the answer is X. So BB matching, so the answer is this guy on the left. R is all alone. That's what it says here. Power property of logarithms is this guy. Okay. You have more choices. You have more choices. It says the same base, but technically you can use also ln or base, common base 10. Both are okay. What happens? Okay, let me finish this. This is the answer. We're done. Logarithm base 2 of 97. That's it. You left r alone. You left r alone. Mission accomplished. Solve means getting this r alone. We're done. I will show you the second method. You can type this in. Oh, you're already here. First, they want us to take this logarithm. Secondly, they want us to round this into 4 decimal places. We're not done yet. That was part A. Part B, how can you get rounded this into 4 decimal places? Your calculator cannot compute log base 2, right? Can you? No. How can you get an approximation for this? How? Change of base. Change this into log base 97 and log base 10 of what? I put 97 to the top? 2. And compute this up to 4 decimal places. Okay? Now I will tell you what other options do you have. It says here same base. No, you don't have to take same base. Sometimes if necessary, you can use logarithm base 10 as well. Why? How is logarithm base 10 is good? Because of this. Yeah, can we cancel these two now? Can we? No, we can't. But how can we get R out of this mess? You can't cancel it, but power rule, it's not this one, the other one. What power rule I'm talking? It's not here. It's in the past section. There is a power rule that says you can bring R here, right? And then you divide both sides by logarithm base 10 of 2. And look what's going on. You got R all by itself. versus what was the earlier answer? It was logarithm base 2 of 97. This is the answer I substituted here, logarithm base 297, but I got here 2 logarithms. So which one is better? This or this one? Which answer is better? Which one? Alright, let me tell you which one better. For part 1, if the question is asking exact solution set, this is better. But if there is a part 2, they want the approximate solution. No calculator can do this. No calculator can do this. You need to change it to here. So this is better for approximations. So depending on what question asks, you may want to choose one option. But if you go with this one already, can you still make it logarithm base 10? Yes, you can, as with a change of base formula. And by the way, you can also choose ln. ln is another option here. Instead of, if you don't like logarithm base 10, your calculators can also do ln. So go with ln, then your answer will be ln of 97 over ln of 2. So you have 3 options in step 2. You either go with the same base 2, you go with base 10, or you go with ln. 3, okay? So you can do that in here as well. All rest of questions. We will continue tomorrow.